This should be result. Excellent. Stream. Oh. Yeah. This is actually working. Let's mute this so that I'm not distracted. We are here. We are on air a bit sooner, but that's fine. Hi all, welcome to the live stream again. I'm Marco, CTO at Memgraph, and we are back live streaming stuff after a long pause. I'm also in a new location, so that's also nice. Today the plan is to wipe code no more or less than a database on disk, figuring out all the transactions and intricacies of the storage itself. Here I'll actually switch to the code quickly, and then we'll get back. If I go here, I actually have stuff already started. It's not totally from scratch. Here is open source repo disk wipes. I actually started it yesterday, but the code I was wipe coding for the last few weeks, figuring out different things and how to actually use the tools. There is a lot of stuff already in progress. Basically, the idea is to build simple graph storage backed by the disk storage using Arrow and Parquet. Basically, experimenting with these two options, and then on top of that, building the transactional stuff. This is all these things here. Maybe I can make it a bit bigger. All these things here. So there is a bunch of different concerns there which have to be done. I'll explain a bit later, but basically the main goal is to figure out benchmarks and transactional guarantees. We're gonna use this Hermitage repo. It's actually loaded here. It's work from Martin Kleppmann. It's a really comprehensive set of tests and different properties for different databases. I'll explain a bit more in details. But basically, yeah, figuring out different implementation details and testing, essentially benchmarking and figuring out correctness guarantees based on this test. Actually, the idea is to implement or try to implement 3 isolation levels. Actually, no isolation, snapshot, read uncommitted, and read committed isolation levels. I'll explain that a bit later when we get there with different tests. And yeah, that's more or less it. We have a plan. I mean, bigger plan is if this is gonna be successful and we have a valid implementation, then is the let's say stage 1 goal is to publish embedded graph storage library. I hope we're gonna get there, but yeah, we'll see about the outcome of the experiments. Probably today I'll only cover these 3 isolation levels and some benchmarks, and then we'll see about maybe if I'm super quick with vibe coding and cursor helps me, we can cover indices and constraints and maybe something on the query side as well and the API, but we'll see. That's the that's more or less the goal. And then the second aspect of the whole thing is, of course, vibe coding. Recently, that whole thing went crazy a lot, but I'm super enthusiastic about all of that. And here is the cursor landing page. Cursor is the development editor. Yeah, disclaimer, this video is not sponsored by Cursor. Is like a great tool to actually accelerate coding. It has a bunch of features. We'll go over them and try all of them in the code. But yeah, idea is to use Cursor to actually accelerate us. I think Cursor is not magic. It can't solve super hard problems. You still have to think a lot. But it helps massively with refactoring, and integrating code. Is very good at integrating code into the existing code base. I think the team there is doing a really great job. Yeah. All that being said, yeah. As always, like, share, and subscribe. Hit the bell icon to get more of these content in the future. And yeah, let's get started actually with something meaningful. Probably something simple first, but we'll see. So actually here I have the cursor. I was playing a bit with the graph viz of the whole project. Graph viz representation. Let me open that. I still have to learn a bit of these bindings, but yeah, let's make this a bit bigger. So this is more or less how the code is currently structured on a high level. Is that visible? Yeah. So we have the graph structure itself. Basically, graph is an object, is a class in the code base, and the main point is actually how to serialize data into the disk storage. And then graph has like subcomponents, the page storage and different mutex stuff, because the point is to figure out a graph engine which kinda can work without any serialization level, just writing stuff as you requested it, but concurrently it works if you call it. The idea is to store the graph data under arrow or parquet format. I actually have really interesting results, benchmarks on that side. Maybe somebody actually knows like arrow and parquet in details. I'm basic user at this point, so parquet seems very good dominant strategy for what we are doing, even though these things are really connected. It's not one thing or the other, but yeah. Anyway, there is a graph which holds the data, and then there is layer of transactional access. There we have much more concerns, and the code is much more complex. So it's gonna be fun to see how Cursor can help us there, because here we have to think a lot for different isolation levels, for commit logs, because as soon as you start executing concurrent workload against something which provides transactional guarantees, there is a lot of concerns you have to satisfy. And yeah, this is actually a bit wrong here. This is generated, of course, by Cursor. We will actually adjust that a bit, but more or less it's there. All these components actually exist. The question is just how are they related, and yeah, we're gonna change that for sure. Yeah, that's more or less it about the structure of the code so far. There is also, so can you see this? Yeah, I'll move myself a bit here. Under storage, oh yeah, in addition to arrow and parquet, we gonna use rocksdb for, basically my idea is to use it for indexing. but probably we'll see if we get there. Probably not today, but yeah, if we are super productive with cursor, maybe we get there as well. That's why there is the rocks folder here. But yeah, we'll get there. And then two main things are graph and graph transaction. These are the implementation of these two things. What I want to say? Graph is basically here. Yeah. So let's pick up something. Let's pick up something which is relatively straightforward. Oh yeah. In addition to that, so I have tests for transactional stuff. It's here. It's actually currently only one test, which is testing the dirty writes anomaly under transactional systems. That's the test about it. And then we also have like a slightly bigger benchmark, which is testing how fast we can ingest data. Currently, it's only about ingestion. But we're gonna extend it, and it's super fun to actually use to see how powerful cursor is on these things, because it's fairly complex code at this point. It has a bunch of stuff in there, but basically we are benchmarking in C++, and cursor is generating. So this code is totally generated by cursor. I barely write anything myself here. On one side, and on the other side there is also a plot benchmark script. This is 100% generated by cursor, and it produces a really nice diagram. Let me show you that one as well. So under here we have these diagrams. Sometimes they don't work for some reason. I moved that from the private repo. Link address, will this work? Nope. Anyway, we can rerun this. We can rerun these tests. Maybe I can zoom in here. Yeah, this is not visible. I moved that from a private repo. They should be visible here. Check that. That's basically the same thing. Now here I don't have it. Last version of it. Will this work? Yeah. Okay, good. So basically, the benchmark script and the plotting script are producing these nice diagrams. It's super nice. So there is a bunch of stuff happening here, and yeah, let me please comment in the thread if you know the details. But let's say results are super interesting to me. For example, the first thing is import time versus batch size. So depending on the batch size, actually the whole storage is organized in pages. So there are pages for nodes and pages for edges. And then depending on how big is, and currently these batches are the same size. So depending on what's the batch size, what's the number of items in the page, this is how much time the import takes. So we are importing, I think in this case was 10 million nodes and 10 million edges, and basically the best batch size is 1,000 in pretty much all except maybe this one. So yeah, 100 and 1,000 are the most interesting batch sizes in terms of the import and throughput. Yeah, there is that's important. This is throughput, and here we are comparing arrow and parquet. Basically, the parquet is organized in a way that we store arrow serialized data in arrow under parquet. And what's interesting to me here that there is not much difference between arrow and parquet, while and it's not visible here, while parquet is much smaller on the disk size. Of course, after a certain amount of after a certain size, let's say after 1,000 elements in a page, parquet compression kicks in, and it's super, and it's let's say 4 times smaller in terms of sizes of files on disk, while the throughput and throughput throughput is very comparable. I mean, arrow is a bit better in terms of time, but it's very similar. It's not that much of a difference, if you ask me. At least these results. Yeah, that's on the batch size. I mean, there is a lot of results here, but more or less they are similar. Where is the... Yeah, the other diagram is this one. Let's make this a bit smaller. So this one is also interesting because we are visualizing a number of threads and how fast we can ingest stuff. And I'm using M1 Mac, and as you can see here, it's kind of really nice visualization. It's kind of logarithmic line. Basically, this when we increase number of threads, there is much much higher throughput for higher threads, and then it's getting a bit lower at the end. It's kind of slowing down. But again, and also absolute numbers here are interesting. So basically, let's take these 8 threads on that configuration. We can actually ingest 2.5 million edges per second and almost 1 million nodes per second. There is a difference. Edges are pretty lightweight. Nodes have, I think, 10 properties on each node, randomly generated. And again, this is a very basic setup. So my idea is to build layer by layer in terms of complexity. This is without any isolation, any transactional, any transactions included. This is just putting in the data on disk using the partitioning that we defined and the arrow/parquet formats. Okay, this was our benchmarking. Let me just try to run really quickly the benchmark itself. I think so. Here we have the terminal. It's a bit I'm using the terminal as well because it's a bit bigger screen, so it's easier to see. Let's compile. I think we should be able to compile. Yeah, this is just this is the current state. So we have some basic unit tests here, or I mean, it's a bit more than unit tests, but yeah, some basic tests, and then we can actually run also the benchmark by running benchmark. That's the C++ benchmark file. It's actually testing arrow, read uncommitted. Oh yeah, I was also running the read committed, but the results are pretty similar, if I recall correctly. But we'll rerun that, and yeah, different thread counts and stuff. So this is how we run benchmark. And I mean, I already mentioned, but let me go back. We don't need this anymore. So this is the open source repo. You can pull it. I mean, it's currently empty. Only that PR is there, but you can check out the code and suggest anything on the PR. Feel free to do that. Okay, that's about benchmarking, testing. I think I explained more or less the current status. Let's do some vibe coding finally with cursor. What is first? We have a few of these to-dos. Partitioning, that's all a bit bigger. Oh yeah, maybe let's go straight into the problem. So here is the code. We have the transaction. What we actually did, a few days ago, what I actually did a few days ago was to this file. So that's the implementation of transactional graph. Basically, it has basic. So maybe I should explain first what's the idea. The idea is to have like a similar interface as RocksDB, where you define a database and then you get like a transactional wrapper around database. So graph is essentially pretty basic structure which has here are some private methods to actually get files, but yeah, add nodes, add edges, get nodes, and all of that is kind of partitioned. You get out some results from these pages, whatever is the partitioning schema. We're gonna also, the idea is to have different partitioning schemes under the hood. That's gonna be responsibility of the graph object itself. But yeah, the graph object itself is very simple, except it has these mutexes here to actually being able to execute concurrent calls. It's the idea for this object is to be concurrent, safe in concurrent environment. So that adds a bit of complexity to the whole thing. And then we maybe a simple graph example, and here we have other stuff as well, but I just have this file as a something I can quickly test different things. So for example here we initialize a graph. Is this enough? Yeah, we initialize a graph. There is a data directory and what is the page format, and then once there is a graph, we also create a transactional graph, which is another object, and then we start running transactions there. So we begin a transaction and then we try to get stuff in. There are other objects like commit log and other concepts in the transactional graph. I'll actually explain that a bit later and when we get there. But one of the problems is this one. So this is one of the things that cursor generated, and I didn't really notice because it's vibe coding. I got like multiple objects which represent transaction at the same time, and I had one nasty bug because of that. I mean, for sure there is more bugs, but I noticed one nasty thing, and then the question is how to unwind that. And of course, I could now do my own stuff and just figure out something on my own. But let's use actually cursor to figure the solution. I'll start a new chat here, and we have a graph transaction file. So if you click here under add files to cursor chat, that will add a file here under the chat in the context window of an LLM, whoever will generate that response. And then the idea is to get this thing solved by cursor. I'll just copy my to-do here, even though that's also possible to add in the chat, I think. Now if I Control L, Command L, yeah, this is actually, I added these lines in the context, and I can ask, for example, transaction are copied times there should be only one. Rewrite the code under time. Make it less prompt. Let's try this prompt. Now cursor is generating a bunch of stuff. What is transaction changing the? So basically I want cursor to get rid of all of this and having one transaction and then reference that transaction later on. Is this working? Yeah, all is working. So now cursor is doing something interesting. I think it's not doing what I wanted it to do. Yeah, you can click here, for example, you can go to the, we have unique pointer. That's interesting, because we got unique pointer to a transaction, but that seems like a good idea, because unique pointer means that you have only one. The ownership is strictly whoever owns the unique pointer owns that object as well under the unique pointer, so that's good. But we still have this thing here which is completely wrong. And now, it's possible to actually go through each individual lines changes and then just accept these changes here. But this seems wrong to me. Cursor just wrap everything under unique pointer and that's it, but the actual problem is not solved. So I'll try again. Where are my objects here? Let me just what's the binding command B? Yeah, this thing here. Let's add that to the chat. No. 3. Active committed aborted. I mean, it's also possible to do here something with it's not necessarily, this is not necessarily wrong, but yeah, I'm trying to get something better from cursor, because we have to be careful with moving objects and figuring out what's, making sure everything is correct. But yeah, one of the things you can play with it multiple times, so you don't, one of them might first, like, reactions was just to accept all of these things, but then you can end up with a huge mess. I think you can prompt cursor multiple times to actually get better things, because yeah, with more context, with more details in the context, it gives you better results. we'll see what's gonna happen now. Yeah, this is a bit, sometimes it takes a bit longer. That's why one other thing is also probably it makes sense to break these files into smaller files, because then the whole process of generating changes is faster. And this is today this is a bit slower than usual. Usually it generates much faster. What's my internet speed? Yeah, I'm good. What to say today? LLMs are a bit slower. Now we have something. Oh yeah, okay. Now we have. Okay, now we have a bunch of stuff happening there. Let's see. Okay. This is actually something aligned. I mean, to be honest, I don't have exact idea what to do. I'm just prompting for a better code, and we'll see what we end up having. Yeah, one more interesting thing. So now we have these changes, and these changes are I'm actually not sure if somebody knows how does this work. Let me know. But these changes are actually applied to the file, because if we do git diff, we have changes applied, and yeah, probably it works through the git already, but we can actually accept this or not, and then I guess cursor is kinda automatically playing with the staging of the changes. So, but since this is already applied to the file system, we can actually what's the terminal? So no, we don't want to update now. Can you see this? I hope so. So here we have we are in virtual environment. We don't need this. Actually it's not. Let's go under the build, and if we call Ninja, we use Ninja to build. This is again, so now cursor generated some code, and it of course doesn't compile. I mean, sometimes it generates something which compiles immediately, most often not. And then cursor is using, I guess, language server protocol to lint. It's called linting stage, and it's iterating on the errors and fixing on the go. That's super nice. But sometimes it can't. I think that language server, I also don't know exactly how it works. It doesn't find all the compile time errors. But what's funny here, you can actually add into the context the whole terminal. So let's say this thing here, and then just say fix. So now cursor will try to fix this error. Seems like it's still doing something. Yeah, we didn't even check. We're gonna, once we figure out all the compile time errors, we're gonna get back but to the code. But where is the graph transaction is actually a problem, but also Hermitage C++. That's the test. So if we compile again, now we have like it's we get rid of the compile time errors, which is amazing. This is like super good because you don't have to spend time, especially in C++, because C++ you can spend a lot of time figuring out what are these errors and how to fix them. And sometimes, I mean, sometimes they're really dumb in terms of some basic stuff missing or whatever. Anyway, this is now compiling. Now we have compilation done. That was good, but what about test? So the first line of defense after compilation is ctest. We are just running all the tests here, and as you can see, all my tests currently are passing. Again, we don't have huge amounts of tests, but that's also one of the strengths with generating with LLMs and vibe coding in general. You can actually generate a bunch of tests relatively easily. So yeah, we'll get there as well. So tests are passing, which is amazing, and I think now we have code is there, compile is happening, and the tests are passing, and we can actually inspect what is there. I mean, you don't have to follow that exact procedure, but I found that most of the time the useful thing. Okay, now let's get rid of cursor window. That's done by this. Yeah. So instead of active transactions, we just have under begin transaction, we have transaction ID. It's generated here by next transaction ID. That's the atomic integer. It's fine for now. Active state is active, and entries. These are the updates and stuff which is added to the transaction. So yeah, this is good. Let's accept that. And then we have active transactions find, active transactions end. Instead of the active transactions, we are looking at the list of transactions. But what is that? That's the adding to the log entry. So adding to the changes to the commit log. That's instead of searching for active transactions, we just have transactions, which is also fine, because we have to find, we are probably missing some check here, because, oh yeah, one other thing, we should probably check here or assert that we have, let's see actually here. So we are checking that transaction is active. If it's not active, we are returning invalid status. That's I think good. Let's accept that as well. And then commit, also the same thing. We are looking for committed. If transaction state, no, this is actually changing the state to committed. Yes, under commit, we want to change the commit. This is now suspicious. No, but this is just so move, raise, that was, yeah, this was the error because like we have to, if we have multiple transaction objects, we have to make sure that we are moving stuff around correctly. That's one of the downsides. So we have this to do, add regular write policy, commit data and time policies. That's a to do from before, where I wanted to play with different partitioning, because in different cases it's different. But yeah, we're gonna, yeah, so cursor is also deleting some of your to-dos. That's a bit weird, because I would like to, yeah, I would like to preserve this to-do. Can I put it here? Yes. Even though it might be, the to-do might be irrelevant. But we'll get back to it later. Accept this. This logic, commit and transaction size. This is now problem with the current design, because here the implementation of the commit is a bit weird, because we are actually writing dirty pages. When we write updates to the files, these pages became dirty, and we have to write them to disk at some point. And here it's just the batching done. But the problem with this approach is that we are actually now searching through the list of transactions, and this thingy here will be expensive when the list of transactions is growing. So yeah, this is a bit of a problem. One of the things is that we can actually implement garbage collection. So we're gonna remove inactive transactions from the system. So this search here will be okay. Yeah, actually, let's leave it. I mean, let's leave it like this here. I'll just put to do here. Because when we found committed count bigger from batch size, this is a bit also wrong, because batch size can be actually committed, can be quite big. No, because we can call commit and it's locked. This is actually serialized. Oh no, that's actually the same logic. Okay, that's fine. Yeah, okay, let's accept that as well. We'll get back there later. Yes, that's, I mean, it's actually the same logic as before, but just we have to make this code efficient, we have to get rid of all the transactions. Yeah, that's okay to do. Reject, we want to keep that. This is just refactor, accept, transaction active, abort. If transaction is not, there is no transaction, this is transaction is not active, that's correct. This is again movement of stuff. That's logging, yes. Yeah, all that got removed from here, which is fine. We are just finding the transaction and then returning the transaction entries. I mean, we are not really using this method at this point, so yeah. Get transaction state is the same. That's okay. What is this? Get active transaction IDs. Yeah, that's also returning the active transaction IDs. That's okay. Committed. This is interesting logic. If committed and ID bigger than last, is this correct? Yeah, last committed. I think that logic was there because of one of the because ID last committed, ID is bigger than last committed. And what's ID? ID is yeah. That's okay, because last committed is something that was previously there, and then we're just getting the biggest number there. Yeah, that's correct. And yeah, as you can see, we have, like, you can just jump in the cursor. You can just jump on another review point. Committed. Here we have write batch. Yeah, that's the actual code to write the whole batch on disk. This batch min max. We are looking for min max between transactions. Why do we need that? Just a moment. No. transactions. Okay. I think we need that for the purposes of locking. Committed transaction reserve. Yeah, I think we also have the logic for writing the commit log on disk, but this is not something critical at this point because we also write stuff on the pages. And that's yeah. I'll actually accept all of this. Accept. What is this transaction? Convert contrast to vector. Transaction. That's actually this logic here. That's how we started. Delete. So we delete all the copy constructors and the move constructors, so that we are not playing with transactions and risking some error. But yeah, we might change that in the future. That's all good for now. I can actually use the cursor. I have unique pointer. Do I really need that? I think unique pointer is not needed here. Any comments? No comments. I think I didn't ask for a unique pointer at all. Is this still compiling? I think it should be. I didn't ask for a unique pointer because begin transaction. That's why you can skip here under other to other files. That's why all these are changed to dot instead of dot to the arrow. But I think we don't need this at this point. I don't like that unique pointer here because it's not needed. And what is happening under transaction destructor? That's just a struct. Nothing is happening. Yeah. This is also. Isn't that an edge case? Isn't that an edge case with unique pointers? Because we're gonna destroy that struct and then we're gonna search for it later on. Yeah. I'm not confident into that. Again, still with languages like Rust or C++, I think you have to think a bit about all these things because memory management and concurrency are not super easy to put in the context yet. So it's still there has to be a certain code review of the whole thing, which is more thorough. Yeah, let's ask cursor for it. So if we go back to the chat, terminal is there. No. Let's put that under add files to the cursor chat. Revert. Let's see what's gonna happen now. Revert the undep I'm trying to I'm trying here to put as much as detail as possible in the human language, in the context, to actually cursor do the right thing that I want. Because yeah, it's without info, it's kind of ambiguous. What do you actually want? Under begin transaction, the unique butter is not necessary. Return a reference to the let's see what happens here. I mean, you often get yes, you're right type of thing, but current transaction. Will it? Will it? Will it change this? No. Yeah, this is now interesting because it's not. Yeah, one of the strengths of the cursor is to actually change the whole code base when needed, but it needs a bit of. Oh yeah, it did it. So it changed back. As you can see, refactoring with cursor is amazing because you can go back and forth these ideas really quickly. Everything automatically happens. Generating, I think it's still doing something. In parallel, we can compile. Yeah, a bunch of errors, but it's still generating stuff, so. While it's doing work, yeah, coffee, I mean, I have the shot glass here, but it's not alcohol, it's coffee. Why is this taking so long again? Maybe I added some lifetime problems with this change. Oh, and now seems that we have transaction. Oh wow, what is going on here? This is something not good. Aligned storage. Why do we need that? Aligned of transaction pointer. Ah no, sorry, this is current transaction is a pointer. No. Oh yeah, overflow, cursor overflow happened. So after 25 tools calls, you can resume the conversation. Nope. Okay, maybe it's better to go back to the unique pointer stuff. But what we have now here. Can you go back? Wait, before we go there, let's understand why is that so much of a problem. We have that current transaction pointer. Current transaction pointer. Transaction storage. What is that? We have some weird. No, we definitely don't want this. This is too complex. This is much more complex. I'm also not super skillful with going back and forth between these changes, so should go back to the original proposal with begin transaction. I'll have to revert back to unique pointer. Yes. Graph. But this is something else happening. Let's leave cursor. Yeah, a bunch of concurrent viewers. That's really nice. Do you guys have some questions or some asks what to actually do here? I have a bunch of stuff in my plan, but yeah, please propose whatever it's interesting. Transaction. Why is that becoming default now? No, I think this is wrong. Now I have everything. Let's compile. We still have test passing, so that's good. Okay, let's actually try to get this code in. What did change? Just the formatting. I don't care about that. Yes, delete default. Move is defaulted. Was that? That was there before. Okay. Yeah, sorry, I haven't spotted that in the first place. Okay, that's okay. Let's accept that. This is just essentially formatting change. Let's move on. So, begin transaction. Why did this change? Begin transaction. That's okay. We get transaction ID. Sorry, I need to think a bit here. This is okay. We had no isolation. This was logical, so noise. I mean, for no isolation, we don't need transactional graph. And that the rest is the same, just with a unique pointer. Yeah, let's do that as well. That's okay. Review next file. Stud move. What? How did this work before? No, sorry. This is actually tx result, value or die. We're getting tx result, and then we're moving that into transact. Okay, sorry. Yeah, that's actually the interesting thing, because here we kinda got the result, and then we took the value, but then this thing here was, I think, whole copied into transaction, while this is not now. This is move, I think. But this is all about changing the point to an arrow, so I'll just accept that whole file. And what is happening here? So instead of that, we are using that. Okay, accepting all of that, but also accept the whole file. Next file. Yeah, here most of these changes are just, I'll believe, cursor that it did all that had to be done. Yeah, this is also an interesting thing. So for some, this is like a quality of life improvement. So cursor actually added errors, but it used the whole old std.c error. Yeah, that's, I don't know how to, and we add the logging into the project, but it's still using the std error. Let's go through this, and then we're gonna fix using the, because we have the spd log in the project defined. So let's accept this. This might be a bad practice or wipe coding, or do you know that meme with wait, that meme with wipe coding versus meme? Where is that? No. No. Where is that? I can't find it now, but when you have like a car with a bunch of stuff there, if somebody can find that meme and paste it in the chat, please do. I'll get back to that. Okay, sorry. Let's get back to the my accepting whatever practice. Accept file. Yeah. Okay. Ninja. Do we run now? Yeah. Okay. So Ninja is there. Is working. C test. Tests are passing. Good. Okay. Let's do one thing. Git diff. Let's see. So these are the changes. As you can see, a bunch of changes done to refactor thing. I also have, so here in the project, I have format script, which will format these C++ files. And then if you run Ninja again, it will compile, because yeah, some now formatting is applied. I don't have the proper setup for the formatting yet, but it doesn't matter. You're gonna survive that. Okay, tests are passing. I also have, so maybe to get a bit out of this, build project, that's the project stuff. I have test all script, which will actually run all the formatting, all the compilation. Boom. Fail to add edges. Now we can't run example. This is now interesting. Instead of me now fixing this, let's go to cursor again, because it's very tempted to go under the code and figure out what is happening. So we are actually, some of our example is failing. Fail to add edges in transaction 2. It's possible to run that example. Example graph. Example graph. That's also the problem because I removed the build. Yeah, and now let's put that to the cursor. Terminal fix. Let's fix that. I'm not sure actually what is happening, but let's figure out. Something is generated. So add edges. Oh wow. This was actually wrong from before. Nice. TX2. Okay, let's. Are we done? No, cursor is still doing something. Let's just run, compile and run in the another thread. Yeah, now it's working. Now this is working. Okay, let's inspect. 3 files changed. What the fuck? So, begin transaction. TX results okay. And here, because we had this speed log. But sorry, what is actually changed here? No. Sorry. I think cursor changed the naming. So instead of TX, we have TX1. Okay, that's reasonable. We have okay, but let's run the whole thing again because running everything is fairly fast. It worked. No, I wronged. I ran the wrong example. Nope, it still doesn't work. Okay. Yeah, I'm also not sure. Is it will it use the same? Let's do fix. Fail to add edges in transaction 2. Yes. Fail to add edges. Transaction. Is this noisy? Yeah, somebody's banging outside. Still generating. Yeah, something is horribly broken here. This is now not good. Not good, not good, not good. Okay, let's get rid of all of these. Begin transaction takes 1, takes 2. Getting notes in transaction 1 fails. Are we done? Yes, we are. To get the bottom, Command J. Let's try to run error nodes, error adding nodes. Yeah. Is that still not compile? Yeah, no, it compiles. Okay, let's figure out on our own what is happening, because I asked twice and it doesn't really work. Adding error nodes in transaction 2. That's under example. So that line here is failing. No, error adding nodes. Error adding nodes in transaction 2. This line is failing. Verify data, get nodes. Result okay. We can also, so I don't have a really good setup for this, but we can also use GDB data to actually get some results out. We're gonna try to debug here. Just a moment. So start debugging. I'll put a breakpoint here. Get nodes. Start terminal. Start debugging. LLDB. Yeah, I don't have, because I started a new project, I don't have the configuration. Workspace folder. I think it's built. Main graphics. That's also one of the cursor. Graph. Example graph auto completion. Okay, and then now if we run start debugging. Terminal, debug console, no. Yeah, we can start, but my breakpoint is not appreciated, or maybe that's too late. Yeah, here, this one is actually fpet, f5. Why you have so many? Let me just add breakpoint. Why is this not stopping? Debug. Maybe I'm not debugging. Maybe I'm not compiling. I didn't compile in the debug mode. Yeah. Sorry. This is. Sorry for the noise. It will stop soon. I probably haven't compiled in the debug mode. Not this. Vibe that describes. Yeah. CMake debug. Yeah, this one. Ninja. Come on. Warning, ignoring return. That's the warning. Okay, yeah, and then F5. Yeah, finally. Okay. Okay, we don't need this. I think what's the. So I used to use a GDB and stuff, so now I'm using cursor. So debugging is a bit different, but let me step over. If is F10. Begin transaction. Okay. Move transaction. TX. TX2. Result okay. TX2 nodes. And this is failing now. So we skip that. We have. Yeah, and now we have to step into add nodes. Okay. Add nodes. Isolation level is, I think, read uncommitted, so we should pass this. Yeah. Page IDs. So what we have page IDs is 1. Yeah, because we have only a few nodes 1 and 2. Status log pages. Add nodes. That will also pass page IDs. Page ID is 0. We are making page 0 dirty. That's okay. Status okay. We are checking status here. And status is what? State is null. That passed. Okay. A log append. Status. That's all good. TX nodes 2. Person 3 and 4. That's also seems to be okay. Step in is F11. Page ID should be 1. Yeah, log pages, yes. Is okay. Log pages. Status, okay. Aha, status not okay. This failed actually. Why did that fail? Let's put a breakpoint here. Start debugging from scratch, yes. Let's completely abandon that. F5. Yeah, this is a bit. No, this is throw. That's not accepted. Sorry, having issue with. These are some. Start debugging. Where is my breakpoint? No. Are you here? Yes. I hope so. Yes, log pages. Log page. Page ID is size 0. Yeah, that should pass. And now to hit continue. Continue is F5. Yeah. Yes. Page ID. No 0. Why 0? Page ID is log. Let's go. Let's step over this page IDs. Is page locked? This one is locked. Yeah. Why page 0 again? That's some edge case. Because we are locking page which is not the one. Okay. Let's try to fix by running cursor again. Seems like there is some edge case. No, not this one. Here. So stop debugging. Stop debugging. Breakpoints. Points. Yeah. Let's use cursor to actually resolve. Seems like. Seems like we have some issue with locking of the pages. Sort page IDs. Wow. This ended up being way more complex than I expected. Let's see if transaction different than 0. Yeah, state only abort if not already committed. And did we have if we are, that seems to be correct. Yeah, let's try to compile. 3 warnings, but that's all good. We have to, I mean, we're gonna fix that later on, but warnings are okay. Example graph. No, this is just not working. Okay, I think we got into a lot of rabbit holes here. No, sorry. A lot of rabbit holes, but let's figure out. Why is that wrong page? Transaction. So we have this problem with the nodes, rollback nodes. No, we don't want to implement that yet. This is no. Mark page as dirty. Yeah, that seems to be correct because we actually wrote this move below. Seems okay. Accept. Yeah, the line is fine. This is okay. Accepting this. We are marking page as dirty because these pages have to be written to the disk. Yeah, that's okay. And then mark all pages as dirty. Add this here. If it fails, unlock pages. Active page lock contains erase. That's the locking of the pages. Yeah, the question is what of these things is correct. We don't want this. It's kind of repeated because we have edges and nodes and then the logic is repeated. That's also one thing to refactor in a better way. Yeah, let's leave that as, no, let's reject this. Reject this and reject this. We left the, I mean, we kind of now left that, change that under nodes, but remove that under edges. What is this? So this is sorted page IDs. Page IDs. We want to log them. Why would we want to sort them? No, we don't want to. We don't need to sort here. Let's reject all of that. And now we're back to these changes, yeah. But let's accept all to to not bother us too much. That's also the benchmark. Rollback edges. No, we don't need that. Okay. Ninja ctest. If we run ctest. Now this is also failing. Yeah, I think I changed too much now. Yeah, I think I changed because now that test is failing. Okay, but let's figure out why the initial thing. We are just going into bigger and bigger rabbit hole. Let's figure out why. Why this is failing. Add nodes, and we have this add nodes method, and then sorry for the noise. Somebody is drilling. Hopefully it's gonna stop. Web pages. This is wrong. Let's just run. Okay, we have log pages, and then for the first thing, there should be why is that now not working? No, debugger is not working. Let's try to restart all of that. Look. How to clean this? Stop. Yeah, that's all stopped now. Hopefully, run start. Okay, now we are back. Yeah, these are some glitches in cursor implementation. That's why I love GDB the most. Okay, let's move on. So log page IDs. Page IDs, we should have page 0 here. Yes. And then if we go back here under main, we don't need this, we don't need this, we don't need that. Yeah, here. Page la 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 la. Graph, transactional graph, begin transaction. Here. Okay. Page IDs, that's okay. And if we continue, F5, boom, we are now node 2. Yeah. Now let's step into is F11. Yeah, add nodes. Yeah. F10, page IDs. Yeah. Get page IDs. And this. F5. F11. Now it's again broken. But okay, let's inspect. And also just double check. So we have batch size is 2 here. So we should have, because we are adding 1, 2. Maybe because zero and 1, 0 and 1. Oh yeah. Three. Yeah, maybe we it's actually correct error. Oh wow, it's now completely broken. Yeah. Close. Cursor got killed. Cursor also got overwhelmed. Okay, so get page IDs, yeah, this thing here. So we are dividing, but with the batch size. So nodes 1 and 2 should end up in divided by 2. Divided by I think we actually have a conflict in the batches. That's actually right, because we have locked transactions. Okay, let's resolve in a trivial way, because this is like actually serialization error, because transaction 1 is trying to access data or trying to write data in the same page. So we're gonna put here 11 and 12. That won't conflict in the page. Example graph. Error adding nodes in transaction 2. The same thing. Okay. One thing is also, let me just do one thing. So common level is trace, because we are using SPD log. I'll just enable trace level, and then if we run this, let's add a bit more logging. Aborted. Fail to log pages for transaction. Nice. Fail to log pages for invalid page is logged by another transaction. Yes. And this is wrong. But why is that wrong? Because now we changed. Aborted with 0 entries, aborted with 1 entries. Yeah, one is because we are adding 2 nodes, but there is 1 page entry. It's not more than that. Okay. Now we have one other thing. We had changed. This is also cursor thingy. So let's, if we place all to the error with spd log trace calls. This is also one of the cursor strengths because no, sorry, wrong prompt. Not error, c error with log trace, because cursor generated a few of these std c error calls, but we don't want that. We want proper tracing, because we can then enable disable stuff. So yeah, let's back here. Actually, what if I just minimize this completely just to see generating? Okay. How is this generated? No, reject this one because it's read uncommitted. It's fine. Error. Yeah, that's what I wanted. Reject that. Accept this. Status add nodes. Yeah, that's okay. One other thing, let's change in place. So can you get the info about transaction? If you click Command K, get the info. If we just, yeah, this is now much better because yeah, we get transaction ID. Let's compile if that's actually true, because I think we have transaction ID. It's failed because of this serializable. I don't know why cursor generated that, but anyway, let's accept this. Let's accept this. How many of these we have? Okay, let's also change. Add that file. No, this is the example. Add to the cursor chat. Instead of hard coding transaction. This should be fine because we can actually next. Yes, this is now correct. This is correct. This is correct. Note result. Getting nodes in transaction, yeah. Yeah, getting better error transaction. That's okay. Yeah, this is really nice because cursor actually found all the issues there. Here I think we don't want to do that. Because of the output. Let's just run benchmark. It's fine. Yeah, this output here is actually tricky to get right, but we can actually accept this. Where are I? There is some. Yeah, this is still C out. Okay, accept file, review next file, define assert. We have changed this, but yeah, let's not that. Let's not take this one. I hope this will compile. Yeah, okay. Example graph. Okay. So we have all this RocksDB stuff, which is irrelevant. Started transaction 1, started transaction 2, main quick test graph. So let's go back. Main quick test graph. Okay. Graph add nodes, add edges. Aha. Oh, nice. Here we have batch size 100, while here we have batch size 2. That's also a bug. Okay, transactional graph. Under constructor, what is actually happening here? We have batch size. Batch size stored here, but we have batch sizes which are wrong. Okay, let's print command K, print both batch sizes from both graph and transactional graph under trace level. So get batch size. Yeah, we probably don't have these methods. And then if I just select okay, implement. Now this is like super nice with cursor, so you can just say implement these two methods under these two methods, and it will probably find the right spot. What did happen now? Uh-oh. No. Something. No. Reject. Sorry, something here. If we do this, let's try to get this through chat. Yes, this is actually correct. Review next file. We have get page size. We have get page size. No, reject that. Let's go back. Get page. That's a bit of ambiguity on our end. I have to main get page size. Yes, this. We don't have page size. Get page size. So that's the page size. Okay, we don't need that. One other thing with cursor is that you can actually get also, if you put here at, and then at, let's say, transactional graph transaction, add get page size under this will now implement the method. We'll see if it's gonna be correct. This is now issue. Let's move on. Get page size. It's just using the graph page size, and I think that's correct. And we should actually, because this is now a bit philosophical, design question, because who is owning the page size information? And I think that should be graph and not the transactional graph itself, because graph is responsible for serializing and how the actual data is stored on disk. So yeah, this is now the problem with building complex software like databases, because everything is connected, and now we have to unwind. So we have to refactor. There is a batch size, this thing here. Why the commit log needs batch size? Stupidity. Batch size is also how many of these transactions we want to batch. Okay, sorry. That's ambiguous. Batch size, commit log, that's under commit log. Let's rechange. Okay. So page size, commit page size. Under, so at transactional graph, rename under commit log, rename size to make it more clear, because yeah, I think this is actually not our bug. We just had ambiguous naming. Hardest problem in computer science is, of course, naming. One of the hardest, sorry. Commit batch size here also. Yeah, commit batch size 1, commit batch size, yes. This didn't. That thingy, yeah. For the graph, get page size, yes. Commit page size, yep. Commit page size, commit log, yep. Okay, so I think we have the right thing. And then, yeah, we're gonna actually add a test for it. Now we're branching a lot in different directions, but hopefully we can get unwind and fix all these things. So if I run Ninja, hopefully this is gonna compile. Let's first test that. Yes, this is compiling, okay. Then ctest, that will probably fail. Yeah, because we introduced some other error. That's fine. We're gonna get back to that. We'll actually test transactional graph for this batch size to get away. So command P, test this one, yeah. Actually, test, add a test to check if both get page size dots under graph and result. Yes. So this is now again cursor stuff, adding tests, super fast, page size consistency, exactly. So we add a test there. I hope that's fine. We can also, so Ninja test, let's compile everything, graph transactional test, it worked, test graph so but is it correct, get page size, redo graph, expected page size 1000, get page size, this is redundant, both have to return the same. Ninja and this. Yeah, all good. We have another test, accept. Okay, that's the test. And then we have that. Example graph, that's gonna fail, but I think we have to make, I don't know how did that pass before, but we have overlap here, and that's correct. So it's correct behavior because the So page size, what's page size? Page size is, yeah, graph page size is 100. Graph page size, transactional. Why is that not printed out? Maybe it's not saved. Yeah, that's one of the problems also, because when I click save, I have to manually explicitly click save. Yeah, now we have 100, and these two are overlapping. So we are storing node. Oh yeah, that's actually what I didn't explain. We are partitioning by IDs. Let's say node ID 1 will end up in the first page or 0 page, and then 100 nodes will end up in that page by ID, and then we have another page. And here we have to put actually 101 and 102 to actually be able to save, because we are not committing these transactions. Commit is at the end. Let's see if that's gonna work. Okay, now edges are failing, I think because of the same reason. Yeah, ID 1, ID 2, ID 1, ID 201. This is gonna pass, I think. Bomb. Okay, failure. Page 0, page 1, and that went to transaction 2. Add nodes. Still something doesn't work. What? 102, 101, 102. Error adding nodes. Error adding edges in transaction 1. Error adding edges in transaction 1. Page 1 is locked. There might be a problem that I'm locking, that I'm using the same page locks for. Okay. How are we doing here? Good, all good, all good. Okay, let's get back a bit to this paging transaction graph. Actually, because we have now trace, let's add that to cursor to fix. What did he say? but that's not a problem. Now this is a stupid example again, because cursor thinks because of the context that the test is failing. The page size consistency test is failing, but that's correct. So I'm gonna just reject that and clear the chat, because what is actually failing is the example. So I'll add main example graph and the terminal. Fix. So because we had wrong thing in the context, it didn't understand what has to be done. Yeah, again, this sorting stuff. Why is getting back to the sort? Log pages. I think the problem is that we are using the same numbers for. If I'm not wrong, I think this sorting doesn't make any sense at all, because it doesn't matter what the ordering of the pages at all. I think the problem is, let's stop this. So no, reject file. The actual problem is log pages. So page IDs. I think we have the same add nodes is using log pages, and add edges is using log pages, while we should have different page IDs. So if we go here, yeah. So let's add more into the context, because here cursor is totally, cursor, I'm using the word cursor, nothing against cursor is great. It's totally missing the context, and that's the main problem. And then let's add. So we need, in the context, we need transaction main graph example, because that's wrong. That has a problem in the test. And then we need transactional graph transaction HPP, because that's what's need to be fixed. And then in addition, we need a terminal to be there. And I think the issue is that log pages method is using the same active page logs data structure, while there should be two separate data structure for nodes and edges. Go and improve. Ah, you're right. So this is a bit strange, because with AI, you're always right. And that's not true. Sometimes you're also wrong. Okay, now we're gonna have fun. Let's go to the beginning. Is node pages. I don't like the boolean. I would rather have like two methods than one method. Active logs. we have two. Active logs is a reference. We have a reference to the... Oh, okay. We can live with it, I guess. Okay, so... Is that compiling in the first place? Yes. And then example graph. Boom, we fix it. Easy peasy. Easy peasy. Okay, that's nice. And what about C test? This is still failing. Okay. I mean, just reflect. I added a lot of complexity with a simple, with attempt to do simple fix, and then a bunch of stuff went wrong. So what can you do? But actually, we had some serious issues there, so that's okay, I guess. Okay. Log pages is node pages. Let's take this. We can refactor later on. We don't have code duplication here. This is correct. Is page locked? Is node pages. Active logs. Yeah. Active log. Unlock pages. Double. Yeah, that's okay. Is page locked? Is page ID. This is just picking. Yeah, that's okay. Status. Try to log the pages. Under edges is node pages false. This is true. Yeah. I don't like this. We can refactor that later, but yeah, okay. So now we have passing test, but Hermitage test is failing. Let's figure that out. So C test, that one is failing, but if we run test Hermitage, test listed below, test failed. Add edges. Hermitage line 90. Okay, so maybe it's time to explain this a bit. So this is actually a test for isolation levels. That's actually where we took the idea from. It's a repo from Martin Klepman. It's actually saying that different databases are doing different isolation levels and calling that similar names. So actual database vendor, when database vendor says I have isolation level X, its actual isolation level, it's probably something else, or maybe similar, maybe not. And for the same name, databases are behaving differently. That's the main point. But here, it's just the point of this repo is just to test for different anomalies. These are anomalies. These are test cases that can happen. Are database avoiding these things, or is it compliant with that particular problem, or is it solving or providing enough guarantees to avoid that particular problem? And again, there is how to go. So Postgres, MySQL, Oracle, different things. Memgraph, it has also 3 isolation levels, and here is the compliance. And we actually for this test, we actually took just the G0, which is a dirty write test. Isolation level G0, no isolation, return committed. So no isolation allows dirty writes, and read uncommitted doesn't allow dirty writes. And here is the implementation of that. Basically, we start a transaction. So we start through 2 transactions. We try to write 1 transaction, and then I think where is the batch size? Batch size is 1,000, or page size is 1,000, and we try to write key node 1 and node 2, and add edges in the first transaction. That should pass. Add edges in the second. Now this is failing. Key 1 should fail. This is actually failing. Sorry, let me just recall what's wrong here. We are failing on line. Failing on line 90. Add edges ID2. This should pass. But this should fail because staging of changes done. There should be error or commit. Yeah, this there are a bit subtle with these things. ID1. First transaction. This should fail. First transaction again writes to 2. That should pass. Add edges in first transaction. But I think that's also this should also fail because that's conflicting. So the second transaction shouldn't be able to write that edge because it's conflicting. The problem is now that we are working on these batches. And by current implementation, it's not possible to avoid let me check that test. So we have a test under memgraph. G0. So select we are actually just testing 1. We are just testing for nodes here, nothing else. We are not testing edges. That's also interesting fact, because add nodes fails for ID1. False. It should fail. I don't know how did that pass before. I guess because of the wrong implementation. Yeah. So many can of worms here. Let's do Ninja and let's do okay, and then test. Yeah, now it's passing. I mean, we might, this is a bit, for the sake of progress, we're gonna move on, but this is a bit questionable because we are changing actually different entities, but they are hitting the same page, and then what's the right behavior, it's questionable. So for now, I think this is good because it's not conflicting and everything else is passing, so we're gonna go with it. Because we got a bit stuck here and I have so much more to go over, so yeah. Let's move on with this. But anyway, like we are passing, that's great. But benchmarks, we need also Ninja and then benchmark. I hope this is gonna work. Let's just wait for. So we have different. Is this now working? Yeah. We have different batch sizes. Oh. But I think this is much slower than before. Is it 19 seconds? Node import time. I think this is much slower now. And also edges were faster. Yeah, also because maybe because I'm streaming or doing a bunch of stuff, benchmark results are not that predictable overall, but yeah. Anyway, while this is running, I'll make another coffee. Let's make this bigger. Okay, let's do a few of these. Oh wow. Uh-oh. All of these should be ignored. I also have here my regular Vim setup. Let's ignore VS Code stuff. VS Code. And these are all artifacts. How did that end up in the... This is wrong, but doesn't matter. I'll just delete that from here. Here. Cursor is running, 8 threads, it didn't break. Yeah, that's fine. It might be a bit slower. What is tested? What is getting tested now? Okay. Doesn't matter. latency, edge input time 1.2 seconds. Yeah, okay. But all of that is good. Let's not, the point is not to benchmark yet. Let's go one here and just test all. So all of that should pass now. If it's passing, I'll just move on. Yeah, but fix also the warnings. I have to fix warnings. For some reason, this is taking longer to start. Yeah. Open build benchmark result summary. What do we have? Latency, average latency. I mean, thread count 1. So this is here. I mean, it's kind of similar. Yeah, okay, should be fine. Okay. No, that's not there. Okay, let's do that. There is some bug with this, but I'll just remove that. RM page error. Is this okay? Yeah. Minus RF G page and reverse index. Yeah. I think format should be called, so we shouldn't have these failures. So we change. Why is client format not fixing this? I didn't run client format. Now it's run. Okay, let's do again. Let's test all again because we reformatted stuff. Yeah, okay, that's actually correct now. Okay, we're ignoring return value of non-discard. That's because compilation is. Let's go back to cursor. Cursor for the win. Command. What's the command to open this? Control Command J. Terminal. Build. Let's remove everything from here. Yes. CMake debug. Ninja. And now we're gonna fix these warnings. Look how simple this is now. So we have a bunch of warnings here on a bunch of places, and we just say stop this, close. You can also just here, when you're in the chat, you can just click this backspace here, and you're gonna delete all that from the context. And what we want to add is the terminal. Yeah, I'm not sure. Fix the warnings. One other thing is also that with AI and cursor, these things are super simple, so you don't have to. Usually warnings are ignored or whatever. It can easily slip under attention, but This is like super simple. Oh yeah, and cursor is recommending this cd build ninja. Let's run that. If we run this, it will run that under the, yeah, here we don't have warning anymore, which is great. Warnings are gone. Yeah, correct. If we do the same here, it's gonna just do nothing because we already compiled. That's amazing. Let's go back to my terminal and test all. Actually format test all. All passing. Now we're wipe coding. Git. Now we're gonna have again, oh, git diff. So let's just recap. This is fine. This is fine. This is not fine. Why did that change to trace instead of error? Okay, let's get fixed. Let's get fixed. So we have a problem here that we replaced error by trace somehow. And also the formatting. Yeah, one other comment is that you can easily slip in these changes. I mean, this is also wrong on a, we also need a transaction number. Let's fix it first. Okay. So let's go back to cursor. Let's remove the context. Let's start a new chat. Under the project, there are some spd log trace that should be error. Fix all these cases. Boom. Now, no. Ah, yeah, that's okay, that's okay, that's okay. Benchmark CPP. Yep. And now we do this. We review next file. Now error begin. Where am I? I'm here. Let's move me here, and okay, that's exactly what I wanted to do. Except because this is an error. Let's move on. An error, accept. Get transaction ID. Accept. Trace error under if accept. What's that? Accept. As you can see, I'm reviewing the code most of the time. So that's the way how we roll. with AI. Error begin transaction, yes. Accept. Accept. Ah. Accept. Guys, you're surprisingly quiet today. Any suggestions? There is. Okay. Ninja, this should up. That should compile. Yeah. Format. Yeah. Okay. Now we have that, but we are missing. The transaction number. Failed to begin transaction. How to say that to cursor to fix that? Let's try. So under SPD logs, there are cases when any given transaction always, when that's the case, always print number as well. Don't note so we want, it's quite specific, so we want to add transaction numbers, but we don't want to hard code. And we have, yeah, now are we changing a bunch of stuff? Example graph CPP. What did I do now? No. Sorry, I accidentally clicked. No. Now I did something bad. Only that. But this is wrong. Edge takes one. Why is that not? Oh, maybe I clicked reject. What happens here? Yeah, that's also one of the problems. It's very easy to click something that you don't want to click, but restore checkpoint. No. Let's repeat. But this is wrong. And this is not about transactions at all. So reject. Yeah, sorry, this is another example. So no. Error in transaction when the error in this one is fine. But main example. But here we don't have the, how did that work? Because it was hard coded, but here we actually don't have transaction. What the fuck? How we have again the error? But we did error here. Sometimes we have to take stuff in our own hands. So I won't fix this because there is no info at that point about failing, so all good. Second transaction. We also changed. Yeah, cursor actually changed this. Changed the data here slightly, so that's not also great. Anyway, we'll move on with that. Trace. Yeah, that's the change from before. Okay. Stop. It's okay. Let's commit all of that and move on for now. One more test. Format. Test all. Should pass. Yes. Okay. More or less okay. Git commit. This was all started by having the goal in mind, actually refactor. Let's push that to GitHub. Yeah. Okay. Okay. This took way longer than I expected, but what can you do? This was from before. My internet speed is okay. bunch of people tuned in over time, but yeah, no comments, please. Comments. This was a joke. Didn't. Okay, Hermitage. Yeah, cursors. Oh, okay. Let's do a few. Let's go through a list of features from cursor. So tab. I think I didn't really use that, but essentially what you can do. Let's get rid of that. So only the code is here. Essentially, what you can do is, whenever you're here, cursor will automatically autocomplete something. It's usually nonsense, like this is totally what I don't want, but if I start typing, for example, for loop, that's a bit better example, because yeah, maybe I want to iterate through nodes. Do I actually have? Nodes defined, yeah. Where is now that for loop? Yeah, so that's pretty cool. How did this disappear now? I think I haven't restored it. Double check. Yeah, I think it's changed. Yeah, okay. I probably reverted it accidentally. Anyway, that's a cool feature. Sometimes useful, I think. Then tab is there. Multi-line edits. Yeah, you can select. Multiple lines and then select smart rewrites. Fix your mistake. And that's not with really smart rewrites. How does? What is that? Cursor smart rewrites in the landscape automatically corrects. But how to use it? Gets enabled. Control K. So Control K is when you click all of that and you just quick edit, and then you can change these few lines of code. I know, for example, this is like maybe end page from rocks. Rename the long variable. What's gonna happen here? So rocks end page. Maybe end page from rocks. Yeah, exactly. This is okay, but as you can see, it was renamed just under this block, and here we have an error, but let's accept this. And then if we compile, I have to change this when I delete build folder. Actually, let's do that as well. So Ninja. this is what bothers me, because I didn't save the file and then it didn't notice that this is gonna fail. And then if we just add that to the this one thing, add terminal, fix. Now this should change that one variable. Yeah, this here, boom. End page. Is that now? Yeah, linking cxx graph. That's fine, but we need this is now suggestion. If you can see this, I'm just hovering over. When I'm over that, when I come to the first character, it suggests me to recall it maybe, and I want that. I want it to do exactly that because it's optional. From get error table, I get optional back, and if I click tab, boom. Now this is not working, obviously. Tab, boom, it's fixed. This is so cool because somehow it knows exactly what's your intention. In obviously some cases, but it works fairly nice. Okay, boom. That's it. That's that. Tab. That's what we just tested. Agent A. I didn't really play with that much. Tasks and then while keeping. Try it out by hitting Command I and instructing a change. Command I. I guess that's the. I mean, yeah, that's I guess any question, because if I agent is that mode. Agent ask manual, but I use that I think throughout. Yeah, I use that. Find context, run commands. Yeah, we use that. Loops on error. Yeah, this is pretty cool because with loops on error, whenever you have an error, that lint stage is constantly checked, and then automatically cursor fixes code which is wrong, which is super useful because otherwise you would spend much time figuring out what's the wrong. Fast edits, proprietary modules, reference code with symbols. Yeah, that's the references because I use that a few times throughout this video. Use images, didn't really use that. Ask the web. Oh. Let's ask something. Web. What's the weather today in London? If this is gonna change my code, that's bad. Why is this taking so long? Okay. BBC weather, Saturday, 14th of June, 23, perfect weather in London. Humidity, pressure. Nice. Okay, that's nice. Add new doc. That's my code is not that documented so far. Let's try that. Add new doc. Inline edit, I know that. Terminal, okay, quick questions. Nice. I mean, I use most of these features, so that's good. Let's do just add new doc. How does that work? So, let's go under graph HPP. let's document that. Manages mutexes for graph pages. This class is used to manage mutex for graph pages. Ne. Manages mutexes for graph pages. That's correct. This class is responsible. But now cursor stayed in the document mode. It's actually now it's suggesting me if I stay here. Sorry, how does that? Reference popular when using library name or add your own using docs. Add new doc. I don't understand how this is actually working. Adding the docs in the context. Nice. CPP. Docs. Official. Is there a C++ document? Of course not. Yeah, not so much. There is missing docs, but yeah, anyway. Library name or add your own docs using library name. If I add, for example, OpsDB. No. Yeah, this is nice, but the library of available documentation docs pages is fairly small at this point. Yeah, by the way, I'm using a paid cursor version, so it's not, there shouldn't be any limitations. Let's get back. This class is responsible for creating and managing mutexes for graph pages. Yes, it ensures that each page has a unique mutex and provides methods to get and release the mutex for a given page. That's correct. Let's leave that as is. Okay. What did happen here? Some formatting. Format. This is stupid because it constantly changes me that. I don't want that to be changed. Where is that main example graph? Main. Okay, that's okay. That's what I wanted. Okay. These were some cursor features. I think it's super nice. Let's commit that. But our standard procedure. One other thing is that the build folder and the issues there. But before that, I need another coffee. It's a bit late already, but we'll do one more. I'll leave you with benchmarking stuff. Build Ninja. That benchmark is running for a longer time. Okay. And we're back. Okay, here the benchmarking is going on. Now we are testing Parquet with read uncommitted. That's okay. So my next step is to add a read committed tests, or at least one. And this is gonna be cool because Cursor is insanely good at generating code based on existing code or refactoring. I really enjoy that part. Yeah, one more time, like, share, subscribe, hit the bell icon to get notified and stuff like that. Okay, while this is running, let's figure out some nice stuff. Okay, cursor, we don't need that anymore. This is bad. Okay, so we have these test isolation levels. Download raw file. So based on that file, test isolation level. Based on that, we'll generate similar tests in our framework. I already did that once, and I was surprised how well it worked. But yeah, let's move on. How to do that actually? I know. So we have that, and then we're gonna copy from the downloads test isolation levels. We're gonna paste that here. So under the project, we should now have so we have this file. I mean, this is just an example because we want to generate similar test based on our current framework. Let's go one by one. So G1A. So we're gonna just generate this test case, but in our framework. So I'll just add that to context. Control L. Control L. I have that in the context. Generate. This is now super cool. So generate me another test under at test Hermitage C++. That is equivalent to G1A using primitives, using C++ prim. So instead of human typing this test, we just leave cursor to figure out another test example. If we go review next file, if you can see aborted reads, G1A is, how did I, this is super nice, aborted reads, I think it is, that is called aborted reads. If you can see, so I selected these lines, but it also included this, obviously, because I don't know how else cursor would know. And this is magic of cursor, so it added a bit more context here. And then it generated aborted reads, which is correct. Don't need this, let's move away. So Hermitage test, G1A, which is correct. And now Okay, we have begin. So all of this is generated, which is amazing. But let's get back to the. So G1A, we have cursor 1, cursor 2. We try to update 1. And then, so this is essentially a test for a read committed, and this is not committed. So for this, we should not select 10. So at this point, we should see a change. And then if we roll back, C1, sorry, C1, C2, cursor 1, where do we have? Double take. Where is this coming? C1 roll. Because we are calling on the cursor is low. Okay, yeah. So rollback, not select. We should not see. Wait, what is that actually doing? So, sorry. Select. Select key, expected get cursor key, and get is just returning, executing that. Fetch all, it's just returning the key. Properties value, key value. So select will just return expected. Aborted reads. So if we update, if not, this says, yeah, 10. I expect here 10, and if it's not 10, fail. This, it should be also be. So I update that, I didn't commit that, I should always see 10. Yeah, okay, so that's the point with read committed, that you only see committed values and nothing else. And then you don't see these dirty reads. Okay, and let's see what we have here. So under our file, we begin transaction. We begin another transaction. One other point is we have some data already loaded under the graph. So we have ID1. There is a node with ID1 already stored. So begin, nodes, add nodes. First transaction updates key key value. Value is 100. Add nodes, that's okay. Second transaction reads key 1. Should see the uncommitted. No. This is actually wrong. I think should see, and what's the 11. The initial value is 11. No. Okay, this is wrong. We have to adjust that. We have to adjust that by let me just run this test. Yeah, it failed. Exactly. Because it should not see. Yeah. So, transaction 2 should see something, but not that. It should be 11. 11. No. No. What did happen now? No. No. No, sorry. What did happen now? I didn't want to change that. Sorry, something got screwed up. Let's repeat. Okay, we got all the results. Yeah. Yeah. No, whether this. Let's repeat. Somehow I clicked something wrong. Yeah. So, transaction 1, transaction 2. Add. I hope you see this. It's a bit small, but anyway. Add not that. 11. Nah. Yeah, when I click up, this is some edge case with Vim. If I click undo, everything goes to, because I'm using also Vim under this cursor editor, so everything goes bad. So we need 101. Initial value is 11, so we need 101 here, and then if a second transaction reads that, it should read 11 here, what's the initial value. And first transaction is aborted, and then if we take a look under test, so we are testing first, so update, we are testing first the initial value, then we abort, and then we test for, again, for the previous value. We have the same test. Second reads again. Second transaction reads key 1, should see uncommitted, should see initial. Abort again, should see original value, should still see original value 11. Yes. And now this, if we ninja and test Hermitage, I hope this is gonna pass, because boom. This is not good. Okay, but we have a passing test. Which is amazing. Let's accept this. And so our implementation of read uncommitted is but the actual problem is that we have a read uncommitted while we should test for read committed, and this is passing. I mean, let me check. Yeah, we need another transaction. Sorry, I forget to change that. Read uncommitted. This test should actually fail under that. Yeah, no, wrong. We obviously implemented the read committed level of isolation. Now that has to be adjusted probably. But okay, that's also a problem. We need to instantiate these tests for different isolation levels. Okay, let's first fix this error here, and then we're gonna go there. But before that, I'll invite a few more people on the stream. And also benchmark results open, build. We also have to draw the load benchmark. Will this work? It should work. We are plotting now the latest benchmark results. Yeah. Open, build, benchmark. Okay, benchmark summary. This is what I got. Yeah. For some reason I have much. I have the benchmark numbers are significantly lower. Not sure if that's because of the stream or something else. But yeah, maybe with my change I degraded the performance. We'll have to inspect that later on. Throughput was higher. Throughput was, yeah. Yeah, okay. Okay, let's go one by one. So no. Replies. Actually, yeah, let's move on. So this is error. Aha. It would be also nice to get from which failed to lock pages for transaction 3. Invalid page 0 is locked by another transaction. So it would be nice to get from which file is this getting common. I think we have here int spd log. Is there a way, let's say at chat quick edit at chat, is there a way to add for boom. Nice. Okay, let's try that. Nothing changed. Error. Time. Thread. Ah, maybe I didn't call int spd log. Where is the best place? Spd log init. Are you sure? Let's test that. I mean, we have and maybe we need debugging to get that enabled. Nope. Add terminal. There format is applied. Posto S, percentage S. What about that? Come on. Yeah. Let's try that. Nope. Still not working. Okay, let's ask ChatGPT. Under SPD log, how to write source log with logging macros. Aha. Aha. We have to inject a different thing, set pattern. And then if that's set, then source log. Can we add that to the set pattern? Yeah. Aha. But I have to add that to every line. No, let's quit that. Nothing. It's not that critical, I'll figure out. Error failed to log page for transaction. Graph transaction 289. Aha. That's my mistake, because on some of these status pages it shouldn't be an error. Because when we are returning status, it's okay, it's not. Or when we exit, okay. It's actually so the log error. This is trace. Sorry, this is a bit my mistake, because I allow that, and these are all valid errors. Okay. no more errors here. Okay, and then graph is also, that's the library function we want to fix. We good here. Okay. Okay, if we ninja that, but why? We changed that before. Maybe it wasn't. Yeah, one other thing is the all tests and stuff. Okay, so no. Test all. Build rm create rm minus mkdir build. First we create a build and then we remove all on that build, but we don't create a new one because, yeah, if I now test all, what the fuck? I think something has changed under the hood. Yeah. How did that all get changed? Oh, git log. No. Git log. Okay, we actually need only, I think cursor under the hood changed something, or because I changed that and I have that. If I go head 1, head 2, head 1. No, that's that. Head 1, head. Yeah, these were the changes. And I have here the boolean. And here we are removing boolean. So yeah, that somehow got there. So long story short, Git is still the king. Git helps you a lot to avoid to get in trouble. You have to learn Git massively. But this is now a bit stupid. We'll get back. So this test is fine. I'll just copy this thing here. We need only that. Everything else is not relevant. Yeah, and now I'm gonna reset. I'm gonna reset this because we had changes. Boom. Yes, we have that file. Okay, let's go back here. Edit. Yeah. how to resolve that. Yeah, okay. 11 bum. And now if I compare, I should have only that. Yes. And now if we go back under here, Ninja, this should now compile and test. Yes, that's okay, but we have the wrong file there. Error. Test transactions. Error. Okay, failed to abort transaction. Yeah, that's actually questionable. Warn. Let's do warning here for now. Error. Failed to log page for transaction. That's info. Oh, sorry, trace. Trace. Okay. Yeah, okay. Let's test that now. Yeah, good. Test that. Boom. Okay. It passed. But let's get back. This is actually wrong because read uncommitted. This test should fail under read uncommitted because we should be able to read that file. Something is wrong with implementation of the get nodes under read uncommitted. But let me. Okay, we have that file. Okay, let's now test. Let's now iterate through the whole loop of tests. So format and test all. So all of this should pass now. Yes. Benchmarks again taking longer to initialize for some reason. Now we shouldn't make a mistake. Okay, that's the loading stuff. And then the test. Yeah, that's okay. Come on. Okay, that's okay. Format test all. Boom. Let's commit. src. Yeah. At G1A. Test. Implementation is version of read uncommitted is wrong. We have the wrong implementation. we're gonna do magic again with cursor. So now we have to add, so my goal is to add another another isolation level, read committed, and that has a bunch of changes which are required. I think we only, so we need to add a test case and add to a cursor chat, and then add transactional HPP, and then we have also isolation level. Where is that file? Here, add to a cursor chat, add another called read committed. Only don't change the graph yet, only add gtest template param. I'm cheating a bit here because I know that gtest needs these template parameters to actually instantiate different tests, but maybe gtest parameter to run existing tests G0 and G1A under different levels. Let's see now what we're gonna end up having. This is correct. Review next file. So read committed, correct. That's the right place to add. What's the time now? Yeah, I can probably stay here for half an hour, maybe an hour. Okay, nice. Review next file. So here we have read uncommitted, read committed. That's in our test with param. In our case, that's actually, this is now the beauty of cursor. So it added this, and in our tests, it's kind of correct. We will examine that, but isolation level, test with param, yeah, get param, which is correct. How do we add? G0. Ah, that's it. Instantiate. Nice. Nice. Will this actually work? Ninja. Because like without cursor adding all these changes, I think you would spend without knowing, and I think I never used this actually. But without knowing that, I think you would spend hours in figuring out this from scratch, and this will probably work. So let's try. Ah, now we have another problem. I think I didn't solve the core issue with the script, but this is nothing to do with our tests. Because I reverted. That was the challenge. Sorry, a bit off topic now, but let's go back to test all. We just need to change this, so put this here and RM, yeah, that. Just to get that out. Ninja, yeah, test, Hermitage, boom. Okay, now what do we have here? no isolation. No isolation is not applicable in our tests. Let's get rid of that. I think you can ask cursor here, but it's faster just to delete no isolation here and no isolation here. We only need these two. We have to recompile to actually make happen. Boom, all passed. Nice. So as you can see here, we have, instead of we were running two test cases for read uncommitted, and now we are automatically running for a read committed and read uncommitted. And yeah, we are beginning transaction. Yeah, let's get just confirmation that we have the right X graph. Should we always have, that's also API question, should we always have that under? So I'm thinking, should we always have, when we start transactional graph, should we define isolation level there? Because we added what does RocksDB do? How do you define? How does that? Right, begin transaction. And share. It's actually under write option. So each transaction defines its own. But actually there is only snapshot isolation, which is they have only one. That's a weird. No, we don't want that. We want a bit more control. Should I? Higher complexity, harder to test, inconsistent behavior risk. Yeah, very well understood and very logical. Like flexible. use per transaction if you have varied workloads and team experience with concurrency models. I think we are good with per database transaction layer. But yeah, anyway, just to make the point, we're gonna refactor that maybe later. It's okay for now. One other thing with vibe coding is that because Cursor is doing amazing job, you can actually refactor these things pretty quickly. The question is only if do you want that. Anyway, let's make. Okay, but I deviated. I just wanted to get. I just wanted to print at the isolation level so that I know what's happening. For each transaction, print the isolation level. Yeah. For each. Yeah, that might be also an assert to check that I have the right isolation level. And then when we change test, it should be the same. When we change the, let's say if we move isolation level from a transaction to the database, then we should get that. Okay, what did we get? Oh shit. We have the function to print isolation level, get param. But we need. Let's test. What does it cost? Boom. So read uncommitted. Transaction 1, read uncommitted, read uncommitted, read uncommitted, read committed. G0, read committed, yeah. And we should probably. That's another point. So let's get that done as well. Instead of this table, which is hard-coded, at the end of the test, we should actually write this table out, spill that out here instead of making it hard-coded. So is that possible? Okay, graph transaction. No, we don't need that. Let's remove that from there and let's do so. What do I need? A hermitage. Instead of let's do that. Control L. No. I want that to be in the chat. Add to chat, command L. Yeah. Hermitage. 10 to, I added that. 10 to 14. 10 to, I need only that. Hermitage is there instead of hard coding. the comment. Supported can you paste on the test outcome, just write the table at the end of the whole test run. This I think I never did that, so I never tried to write a summary after a G-test. No idea how to, I mean, there is probably some after all tests hook, but let's see. Boom. Test result tracker. Nice. Look at this. Look at this. So if we run, okay, isolation level anomaly test formatting is a bit broken, but we can fix that as well. See out. Yeah, for that it's okay to use see out because we're gonna just write that under the hood. Formatting. Okay, let's add that to chat. Formatting terminal. Why is that? And it's a bit all good. Look at this. We have nice format. Everything is good except the tests are wrong. But indeed, like this, I think this G1A should fail under read uncommitted. But yeah, I'll add a bit more and then I'll go to fix them. So I'll add a bit more of these test cases. Okay, accept file, boom, all good. Nice. Let me just see what we have. Let's do format and test all. We added read committed, we added a few of these, that's okay. We don't need this anymore. Yeah, let's do that. This is super nice because we actually, based on the test outcome, we generate a table. I don't know, without cursor, I think that's a bit philosophical, but I think most of people would not spend time implementing that thing, and it's super easy to add. Stuff like this work out of the box. Okay. Yeah, all passed. Just to recompile one more time because I changed Ninja. okay. And if you recall, now I don't have that problem with the build. I can, my build is preserved. Top shit, top shit. Actually, git add src, git add test all. Read committed, isolation level, no isolation, read committed, da, 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 da. But we are only testing for that. Aha, it's easy, it's not just we run all the tests and then at the end we just print results. Yeah, okay. Easy, easy. If I run ctest, build ctest, nice. Let's commit that before cursor fucks up something else. Add params to the push that. Okay, that's about it. Now let's add another test. So G1A, G1B. That one is a bit more complex. What's the time now? Almost running out of time. Yeah, and this is actually fine. I wanted to show, I showed what I wanted to show with that. Anything on the comment side? Not much. Yeah. So actually, how complex is that? Update, read committed, read uncommitted. It should fail. What do I need to confirm that? Read committed, read uncommitted. A bunch of these have to pass. Yeah, that's too much work. I can't make that happen. Okay, let me do a few of the cleanups and then we'll get back to this later probably. My speed, yeah, my internet speed is quite good. Very stable live stream. I think it wasn't interrupted at any point today, which is amazing. Yeah, that's okay. I actually did that, but yeah, okay. Let's go over to those. Maybe we have some low-hanging fruits. AG. The following are constant object. Mark them distinctive. That's the graphics, but that's easy. I will do that later. That's the point about making the throughput. So the point is that under benchmark, you also get some analysis. You can run, the idea is to run the benchmark initially on your machine, and then you get recommendation what's actually the right config for the given database lifetime. And always run. benchmark and all that. This seems interesting. Benchmark to do. What is that about? Sorry, I forgot a bit. Benchmark to do. Isolation. Use isolation. Set true to read. Use read uncom. But we didn't really change anything. Yeah, because we have the same implementation. We actually didn't change implementation at all. Yeah. We need to change the. Now we have to add additional benchmark parameter. Let's try to do that. So, but also here isolation. We set isolation under transaction, but this is not add nodes. If no isolation, we skip, but we have essentially the same implementation. Yeah, we have the same implementation. Yeah, this is also the complexity, because like there's just exponential number of things you have to test. For example, here we also have to test for all the combinations, and the tests are different for different things. That's gonna be fun. But okay. Okay, let's assume we won't change that. We'll just change the benchmark for now, and then we're gonna go. And yeah, this is also one thing. So because it's so easy to generate test cases, and once you have the test cases, you can actually use the compute from all these LLMs to give you the results or to implement the code. It's actually very encouraged to write the tests first, write the test cases, write the options first, because then you can iterate on the results, and that's what I'm kind of doing here. So let's do the benchmarking. So let's add that to the context at benchmark. Instead of testing only one, but I also have to change the plotting. One isolation level. Change the code support no ISO all currently. Let's do that. What's gonna happen there? Isolation level to string. Didn't I have that before? But that's okay. Benchmark result isolation level. Yeah, that's correct. That's correct. Run benchmark, no isolation. If isolation. Yeah, we add here isolation. If no isolation, then do that. Yeah, only graph. We need only. No. Takes graph is just bypassing the stuff. Cursor here assumes where is the constructor? Uh-oh. Sectional graph. Again, transactional graph doesn't have isolation, sorry. No. Yeah, okay, that's correct. If no isolation, we're gonna pass isolation level. And yeah, what just a bit off topic, but I'm focusing on isolation level first, but also we'll test for in the future. We'll test for atomicity, durability, and consistency. Other ACID guarantees, but I think isolation is kind of the most interesting one. I'm not sure, but it because of these multiple levels, it kind of adds a lot of complexity. No isolation. That's correct. If not, yeah, that's correct. Isolation levels are hard-coded. Yeah, that's the to-do. We get rid of that. We test for all 3 levels. Yes. We can get rid of, can comment out some of the, oh yeah. Now this is a bunch of stuff. Yeah. Because we changed the output, probably the plotting also has to be changed. Let's get that done as well. So use isolation, benchmark, but Ninja. Oh fuck. Oh. Okay, let's test all of that. Ninja is working. Test all. If I just test everything. Oh boom, we got heat maps. Sorry. Okay, sorry. This is now interesting. Wait, and now this is the classical struggle. So we got a bunch of data, a bunch of generated code. Let's get rid of that. We have to review all of that. We have another file, isolation level. Let's So this is correct, but okay. Well, here are the results. No isolation, read committed, read uncommitted. Why is that different? Fuck me. Shouldn't this be uppercase? Boom. A bunch of data. So at this point, I think we are a bit overwhelmed. I think I should start splitting these things. But yeah, okay, it's actually working. We have all the latency, throughput, all there. If I open benchmark results, summary. Oh, wow. Detailed. No. Batch size. I lost something. I lost something. I lost something because I had. No, I can't access it anymore. But yeah, it's not really critical to have all of these diagrams. What's the... Why is that lowercase? And I'm also compiling, maybe that's why it's slow. Where is that heat map stored? Plots. I haven't actually run that. Let's delete all of that. Let's run it again. Because I think yeah, this is now okay, but why is that not showing? No, it created a new file. Interesting. plot benchmark and plot benchmark. Ah. This is also interesting side effect of cursor because it just created out of nowhere another file. Python 3 plot. Let's go back here. Kill terminal, new terminal, venv. Yeah. This is not working. Yes. Add to the context. Fix. V 0.8. And what about plot benchmark? Yeah, also that's the error there. No benchmark result files found. Boom. Also doesn't work. Something is broken with the results. And what do I have? Results. Yeah. What about if I get benchmark? No. Get build benchmark read committed per k, for example. I have these numbers for 1 and 2, read committed, and then size, isolation level. Yeah, it's okay, but yeah, plot, it's just not working. But I think I'm gonna just this is now classic vibe coding, like you're just showing the error and hoping that it's gonna figure out. What's happening now? Boom, and yeah, it's working. Top shit. All plots have been generated in the plots directory. Boom. Yeah, this is now wrong because I started it here. I would like them to be open plots. Boom. Node throughput heatmap. Node throughput heat map. Boom. Heat map. What is there? So nodes per second. No isolation arrow. No isolation parquet. But it's actually nice visualization. Not bad. I'll leave both of these, so I have to kind of wrap up for today. I'll leave this in the repo, but yeah, we'll refactor probably all of that together because we can have one script. Actually, maybe I can just plots average heat map by ISO performance score by open noise. Look at this. No isolation read committed, but again, these are the same. We have to change the implementation. Anyway, okay, good. Amazing. Let's hide this. Let's remove. Hey, can I run? Python 3. Okay. Pen build slash yeah, my script from before is still working. Yeah. Actually, okay. Accept this, accept file, review next file. This will just be renamed because these are different. These are different diagrams. Accept, yeah. So I just want to move plots under build. So if I add plot benchmark results, move while it's doing that, let's go here and no rl minus rf plots. Boom. Now we have generating plots. Yeah. Also plot benchmark results. What's the fundamental difference between these? This is working. Accept file. By isol performance score by that's a different plot. Edge throughput by isolation level, that's a different plot. Heat map, throughput heat map. These are similar. have that average page latency versus page size. Average. Open build plots alg node. What is that? Yeah. Okay. That's all good. Just let's rename. Let's rename. But how is this working? Like, what the fuck? Yeah, okay. Let's commit all of that and okay, sorry, rename. Plot benchmark results. I don't know how to change the name, so I'll leave it as is and then change later on. Okay. Oh no. Test all. I have to change test all. Yeah, all good. src plot and test all. Let's see. So we have a new plotting file, that's fine. And then we added changes to run all isolation levels. That's also fine. Oh yeah, let's commit that. Actually, let's just run. So we are here. If we run benchmark, yeah, this is now testing the 7.6 seems reasonable for the no isolation for that batch size. Yeah, running stuff. Okay, that seems to be working. Oh, there is. Okay, nothing there. Yeah, nice. Throughout the whole live stream, there were like 10 concurrent viewers almost always, which is good. Yeah, okay, this is running. That's all good. Let's move here. Actually, yeah, more or less that was all for today. I hope it was fun. Fixed a few bugs, added a bit more as is usual. It's not easy, but yeah, my plan is to continue working on that, fix some stuff, and probably next weekend I'll do another live stream, hopefully with all these tests working, and then we can basically the biggest next thing is indexing. So making sure, because all of this is just adding stuff to the graph. Reads are quite limited at the moment, and then when it comes to reading, then indices are getting serious problem. A serious problem, serious concern. So probably, yeah, I would like to, by the next stream, I would like to fix all these errors and then figure out and play with indexing with RocksDB probably, and then yeah, benchmark everything and see how it performs, and yeah, hopefully that's gonna be doable. You guys are still here. That's amazing. Okay. Let me double check my list. Did that. Okay, all good. Okay. Anyway, thanks a lot for watching. Once again, like, share, subscribe, hit the bell icon, and yeah, see you next time. Have a good rest of the weekend. Bye bye.